Every crashing wave carries power, more in fact, than all the electricity generated worldwide in 2023. But for decades, wave power has been riddled with setbacks. Prototypes lost at sea, busted budgets, and failed startups. That may finally be changing. In 2023, buoys from Swedish company CorPower Ocean survived towering 60-foot waves and kept feeding clean power into the grid. Rather than just floating along, these devices tune into waves with a built-in system that amplifies their motion, extracting more energy per cycle. With commercial farms on the way, wave energy might be on the brink of a breakthrough. So, is this wave tech the real deal, or just another clean energy mirage? By 2024, over 30% of the world's electricity came from renewables like solar, wind, and hydropower. But the ocean remains largely untapped. According to the US NREL, wave energy converters near the US coast could produce 770 terawatt-hours a year, enough for 71 million homes. Push farther offshore and wave power could potentially cover a third of US electricity needs. It's not for lack of trying. Companies like Ocean Links and Palamas once led the charge, only to fold under financial or technical pressure. Even promising concepts like EEL Energy's flexible membrane haven't moved past pilot tests. The ocean is a harsh place, and designing equipment that survives storms, saltwater, and years of wear is expensive and complicated. Unlike wind or hydro, waves are unpredictable and multidirectional. They don't just push, they loop. Turning that swirling motion into usable electricity is no easy feat. That's why we still don't have a standardized wave energy device. Yet the advantages are huge. Wave energy is highly reliable. In California, offshore wind often stalls for 1,000 hours per year, but waves stop for only 200. Combining both shrinks downtime to just 100 hours. Waves also peak in winter, complementing solar power perfectly. Studies show pairing wind and wave power could cut the energy needed to achieve a net zero grid in the US West by up to 17%. Co-locating both can save even more. For example, a joint 100 megawatt wave and 500 megawatt wind project could slash capital costs by up to 40% for wave and 7% for wind. CorPower Ocean is leading the charge toward commercial viability. After testing a prototype in Scotland, the company relocated to Portugal and repurposed the site of a defunct wave farm. By 2023, CorPower's new device, rated at 300 kilowatts, was regularly delivering up to 600 kilowatts. With tweaks, the next model could hit 850 kilowatts. CorPower's buoy is a point absorber, about 9 meters wide, anchored to the seabed. As waves pass, the buoy moves in all directions, driving internal machinery that generates electricity. Its tension system adds a clever trick. It pulls the buoy down between waves, harvesting energy on both the rise and fall. The secret sauce is WaveSpring, a resonance tech that synchronizes the buoy's motion with wave patterns. Even in small waves, it enhances movement and energy capture. Add AI controls and the buoy can adapt in real time, detuning during storms to survive extreme conditions. During tests, 4 buoys endured back-to-back winter storms with record-breaking waves. All survived and resumed operation afterward. Still, long-term durability is a question mark. Saltwater corrodes and constant motion wears down seals. CorPower estimates a 20-year lifespan, potentially extendable to 30 years. That matches wind and solar, on paper, but hinges on robust, leak-proof seals. Environmental concerns remain. Hydraulic leaks, noise pollution, and electromagnetic fields from cables could impact marine life. CorPower addresses this with quieter UMAC anchors and baseline underwater noise studies. But much is still unknown, especially around full-scale farms. That's why careful monitoring is critical as the first farms come online. While WECs might protect coastlines by absorbing wave energy, they could also alter currents or sediment flows. Their structures may become artificial reefs, potentially helping biodiversity or inviting invasive species. In 2026, CorPower plans to deploy a 5-megawatt wave array off the coast of Ireland, scaling to 30 megawatts by 2028. It's backed by Irish utility ESB, Simply Blue, and 39.5 million euros in EU funding. Once live, it'll generate 15 gigawatt-hours annually, enough for 4,200 homes, and avoid 27,000 tons of CO2 over 10 years. CorPower's levelized cost of energy, LCOE, is projected to reach $32 to $43 per megawatt-hour, but only once scale hits 20 gigawatts. For now, the goal is 2,000 buoys, 600 megawatts, which could drop the LCOE below $76 per megawatt-hour by 2035. Their cost-saving secret? Fiberglass and resin construction, cheap, strong, and lightweight, paired with mobile factories. These pop-up buoy plants reduce transport costs and emissions by building locally wherever the next project is. To speed things up, wave energy needs what solar and wind got: subsidies. The IEA estimates $74 billion in early-stage public funding could bring wave to market price by the 2040s. Delaying investment could double that cost. The math is simple. Early funding cuts total spending. Europe's already leading. Between 2007 and 2019, EU nations invested $530 million in wave and tidal tech, drawing $1.5 billion in private capital. CorPower alone raised over $100 million by early 2025. The US and Australia have strong resources, but trail in commitment. With reliable tech, scaling factories, and falling costs, wave power may finally be more than a dream. The tide, it seems, is coming in. What makes CorPower's design particularly compelling is its balance of simplicity and sophistication. Traditional turbines rely on spinning blades, but point absorbers like CorPower's buoy convert vertical and lateral motion into rotary energy through a smart mechanical setup inside the device. This modular approach makes repairs easier and future upgrades more feasible. And because it floats, it's inherently scalable. Multiple units can be deployed in parallel to form an array, like solar panels at sea. Beyond the engineering, the strategic thinking around deployment is also innovative. CorPower's mobile factory model isn't just a logistical improvement, it's a financial and environmental one too. These floating power stations, nearly 30 feet wide and as tall as a building, are expensive to ship. Manufacturing them locally slashes transport emissions and supports regional economies. It's a win-win. The material choice of fiberglass and resin, similar to what's used in boat hulls and turbine blades, is another major advantage. It offers corrosion resistance in salty environments, is significantly lighter than steel, and when produced at scale, dramatically lowers costs. This design philosophy, prioritize efficiency, durability, and manufacturability, has enabled CorPower to build not just resilient devices, but also a viable business case. Grid integration is another key piece of the puzzle. One major challenge in renewable energy is intermittency. Solar dips at night, wind can stall for hours or days. But waves, they're always moving. This consistency makes wave power a powerful complement to existing renewables. In places like the US West Coast, wave output peaks in winter, exactly when solar drops off. The result? A more balanced, stable grid. Moreover, combining wave and wind in the same offshore space is an opportunity that energy planners are increasingly excited about. By sharing infrastructure like vessels, cables, and maintenance crews, costs go down for both technologies. It also streamlines permitting and environmental reviews, reducing project timelines. Of course, it's not all smooth sailing. Ocean energy faces hurdles, particularly in terms of regulatory and environmental impact assessments. The ocean is a dynamic and delicate ecosystem. Every deployment needs to be carefully evaluated to ensure minimal disruption to marine life. That includes studies on underwater noise, electromagnetic interference from cables, and the long-term impact of anchors and moorings. CorPower has taken steps to reduce these risks. Its UMAC anchors, for instance, use a vibration-driven installation method instead of noisy pile driving. This reduces acoustic pollution during setup. For ongoing operations, the company is conducting underwater noise monitoring to track its buoys' real-world impact. Early results are promising, but more data is needed to draw firm conclusions. Then there's maintenance. Saltwater is relentless. Mechanical components face constant motion and corrosion. One of the biggest engineering questions is whether the seals on the buoy can truly endure decades of use. If these fail, sensitive electronics could be exposed to the ocean, leading to costly failures and environmental concerns. That's why the first commercial deployments, like the one off Ireland's coast, are so important. These projects aren't just about generating electricity. They're about learning how the devices age, how ecosystems adapt, how to maintain performance year after year. The insights from these early wave farms will shape the future of the entire industry. Wave energy's timing couldn't be better. As the world electrifies transport, heating, and industry, demand for reliable, low-carbon electricity is surging. Solar and wind are leading the charge, but they need reinforcements. That's where wave power fits in, not to replace, but to complement. The International Energy Agency estimates that early public investment, around $74 billion globally, could push wave energy to market readiness by the 2040s. That might sound like a lot, but it's a fraction of what was spent scaling up solar and wind. More importantly, delaying support could end up costing double. The payoff could be enormous. In terms of raw potential, wave energy could meet 10 to 30% of global electricity needs, especially in coastal nations. Combined with offshore wind, it allows countries to maximize marine resources without building new land-based infrastructure. Europe is already leading the way. With over half the world's wave energy patents, a dozen grid-connected test sites, and a growing number of commercial deployments, the EU has built a strong foundation. CorPower alone has raised over $100 million in public and private funds, proof that serious money is starting to flow. In the US, interest is rising too. Oregon's PacWave test site is nearing launch. California has passed legislation to explore wave farm locations, and the federal government has approved over $500 million in ocean energy funding since 2019. Despite recent setbacks, Australia, despite its enormous wave resources, remains mostly on the sidelines. Less than 2% of its renewable energy budget has gone to wave power. But research groups like the Blue Economy CRC are pushing for change, hoping to tap into the country's vast Southern Ocean potential. The tide is turning, slowly but steadily. CorPower and others are showing that wave energy isn't just a dream, it's a solution. Quiet, consistent, and clean. And with the right support, it could help power the planet long after the sun sets and the wind dies down. As we chase climate goals and build a zero-emissions grid, we'll need every renewable tool at our disposal. Wave energy has waited long enough. The next few years will show whether it can ride the crest or be washed away. So, are we finally ready to ride the wave? Time and tides will tell.